Hey everybody, we're here for day three um, of Advent to Code 2015. Again, we're just trying to solve problems to get us back in the flow of things. Um, and it something too that just I thought about is I just enjoy like trying to solve problems. And I think one of the things that like AI does is it changes the way you solve problems. So it used to be back in my day, we would do things in like C, but you could ask people before me and they're like, "Oh, we had to write ours all in machine code or assembly." Right? And like we've built these layers of abstraction. And I people ask me all the time like, "Hey, what do you make of programming an AI? Is your job going to go away?" And I don't think it is. I think it's just going to be different, right? It's like it adds like another layer of the abstraction to what happens. And so but I enjoy this puzzle problem solving part of it. And as I was thinking about the other day, I think you still have to solve problems with AI. You just solve different problems, right? In any way. So the hope is that we can keep up with our puzzle solving skills and be able to use them whenever, wherever we need to. So um, that's what we're doing here. So let's start with day 3 of 2015. It's called Perfectly Spherical Houses in a Vacuum. Santa is delivering presents to an infinite two-dimensional grid of houses. He begins by delivering a present to the house at his starting location, and then an elf at the North Pole calls him via radio and tells him where to move next. Moves are always exactly one house to the north, south, east, or west. After each move, he delivers another present to the house at his new location. However, the elf back at the North Pole has had a little too much eggnog, and so his directions are a little off. And Santa ends up visiting some houses more than once. How many houses receive at least one present? Okay, that doesn't seem too tough. Sometimes when you hear infinite things, it can get a little scary. But the question we're just trying to answer is how many houses receive at least one present? So we really just need to track like which houses have been visited. We can probably do that with like a hash set. So let's see. For example, this delivers presents to two houses, one at the initial location and then one to the east. Okay. And then this one delivers to four houses in a square, including twice to the house at the starting position. Yeah, so this just moves up type thing. Uh, this delivers to only two houses. Yeah, because it's just going up, down, up, down, up, down the same way. And our puzzle input is just a giant string of things. Okay, again, this doesn't feel too hard. If you know what a hash set is, I think this is an easy solution for a hash set, right? What we're trying to do is track uh how many houses have been seen. And so that's a great way to use like a hash map or a hash set, right? Imagine like a very, very naive approach might be, oh, what if I just create this giant grid of like this giant array and just mark places that have been seen? um I mean that would work too, but again, because it's infinite, you don't know how far you're going to go in one direction. You may have to continually be updating your thing, but in this case we're really just interested in how many, and so we can do that with the hash set pretty easily. So let's get into it then. uh so we want to have a hash set, and we probably just iterate over the we'll want to have our current position. And then we'll wait and see. It may want us to know. We'll just want to loop through all the characters of the input. So if it's this, I guess I need these both to be mutable. if it's this, we want the to increase the x direction. So we'll say cur dot 0 plus equals 1. And if it's this, we want cur dot 0 minus. I can type, I promise. And then if we're going up, we want to do cur dot 1 plus equals 1. And if we're going down, we want to do cur dot 1 minus equals 1. Otherwise, nothing. Okay, oh. So we want to insert the first position. Oops. Okay, like that. And then down here, we want to just do scene.insert cur. And then we'll just return scene.lane, which is actually a U size. Okay, I mean, that doesn't seem too crazy out of the way, right? Let's just see if we got it. That's the right answer. Okay. So what did we do? Again, the thing that should be going through your mind is, if I just need to solve the problem in question, and what data structures or algorithms are available to me, right? We've seen before a lot of days where you're like, oh, it's a graphing problem. Oh, and this one technically kind of is a graphing problem, right? We need to like traverse some graph using these arrows that tell us where to go. But the essence of what's being asked is like, how many points have I seen? And that's where something like a hash set is really useful, right? And the way to think of a hash set is just a list of an optimized list of things that have of things in general. In this case, the list is places we've seen. So if we do an insert on a place we've already seen before, it won't add it to the list, right? Because we've already seen it before, so we already know it's in there. If you'd like to know more about hash sets, we can definitely talk about that. But the idea between a hash set is just like add items to it, and I'll keep a list of like unique items that I've seen. And you do all kinds of other operations with hash sets, right? Like maybe you have two different lists or two different hash sets, and you want to join them together. That's called a union. Or maybe you have two different sets and you want to say like, give me the ones that are in this set but not in this one, or give me the set that, or give me a list where of items that are in both of them, right? These are things that you can do with sets. There's all kinds of cool things you can do with sets, but one of the simplest things you can do with sets is just, does this item exist, right? And so that's what we're really asking with this problem is, does it exist? And so we can just keep a track of all the houses that were visited, including the first one. And then once we're done, that list length is the unique set of things that you visited. And why this might be easier than an array is, remember, I'm only tracking at this point the positions, right? I'm only tracking each of the positions, the XY locations of where we visited. So we could clean this up a little bit, right? So we could say like, maybe we have a struct point and we have an X, which is an I size, and a Y, which is an I size. And we could like do this operation inside of this operation. So we could say we could impl point, and we can say ones might be interested in. We probably want a new with an X eye size, Y eye size. This is where like the AI would actually kind of be nice because it could do all this stuff for me. But what do we want to return? Just a point X, Y. Oops, I did that wrong. Something like that. And then we could have like an update that takes a character and gives me a new one of myself. Something like this, and then we do this logic that's down here. Is there? I'm trying to remember how you do multi-cursors. I think it's like, there we go. So we do something like that, and then we return next. Okay, so we've done some abstractions here. We've said, oh, I can create a point. I can make a new point, and I can then do an update on points to get a new version of myself. Maybe we just call this next. So we can say new here. Oh, I need to implement some things for this to make this work. So we'll derive equal, partial equal, partial ord hash, I think was one we have to implement. Then we can simplify this here, and we can just do scene insert. Or let's see, cur equals cur dot next. Oops, what? I don't even know what I did there. Cur because it does not implement. Oh, we do need to implement the copy. Why doesn't it like? Okay, there you go. We just have to implement these because this is going to like make a copy. So we do that. Okay, that's potentially cleaner. Again, we're abstracting away like the logic of dealing with the point or the vector, right? And then we're using it here. So there you go. Maybe that looks a little bit cleaner. Seems good to me. Should we move on to part 2 then? Part 2. The next year, to speed up the process, Santa creates a robot version of himself, Robo Santa, to deliver presents with him. Santa and Robo Santa start at the same location to give delivering 2 presents to the same starting house. Then take turns moving based on instructions from the elf, who's eggnoggedly reading the same script as the previous year. This year, how many houses receive at least 1 present? Up, down, 3. So up, down delivers to 3 houses because Santa goes north and then Robo Santa goes south. I see. Okay, they're alternating. So it's the same problem. They're just alternating. So Santa takes the first one, then Robo Santa takes the second, and so on and so forth. And so this one changes because Santa went north and Robo Santa went south. Okay, so this problem at a high level hasn't changed, or like at like this internal level hasn't changed much. Is now you're just tracking two things, and we want to calculate them in alternating fashions. So the harder part will be like, how do we do the alternating part? But let's just start with where we were in part one. So we'll have like cur Santa, and then cur Robo Santa. So we'll have like two starting points, and then we'll have like a scene Santa and a scene Robo Santa. Doesn't like the spelling. Okay. And then now we just kind of want to alternate. So I mean, it feels like the easiest thing is just to see if we just do like a Santa's turn equals true, like this, and we track them both on their own. So we'll say like if Santa's turn, we're gonna do this, and then we do Santa's turn equals false, else it's gonna be this, except we're gonna have like this. Why doesn't it want to format that? Am I dorking up? So we're going to return scene Santa plus scene Robo Santa lane. There we go. That fixed it. Okay, I just had two OKs at the bottom. Okay, so what's different, right? We now have like quote unquote two Santas doing their thing. And so we're just going to track two of them. We have a Cur Santa and a Cur Robo Santa. And then we have a scene, what Santa has seen, and then what the Robo Santa has seen. And then we're just going to alternate between the two, right? We're going to say, okay, put this in, or put this in, switch it. Oh, I need to put this in, switch it. We could probably do this. Santa's turn. Can you do this? It's like this, huh? So we're going to have Cur Santa. If it's Santa's turn, we're going to add to his. If it's Robo Santa's turn, we're going to add to his, and then work our way through. I presume that's going to find the solution. We can try and refactor some of this a little bit. Oh, it's not the right answer. Okay, what am I doing wrong? Oh, I want to do the union of these two houses, right? So Santa and Robo Santa may have seen the same house. Oh, I can just have one scene list. I can still have just one scene. like that. Is that what I was probably over engineering that. There we go. Okay. Yeah, so my original thinking was we'll track them both and we'll add them. Again, I could have used the set stuff to say, oh, do the union of the two and get a distinct list. But because we're only interested in the house's scene, we can track them both. We really just need to know the positions of where Santa and Robo Santa are. And then as we're moving them, we need to do those inserts. Okay, yeah, that feels good. I thought maybe we might want to do some kind of like, oh, should we track Santa as well as their hash set in like a struct? But because they're both using the same hash set, this probably doesn't seem necessary. Right? Yeah, okay, that feels good to me. Pretty easy. We're just alternating between Santa's turn and not Santa's turn. Part of me wonders if there's like an unzip thing where you could like split between the two. This is fine though, right? Like what I was thinking is imagine a case where you have an input of, so like you have this iterator, could you like fill up two arrays and then just use one array and go through it, and then use the second array and go through it, both starting from the beginning? Then you don't have to have this for thing right here. This seems probably just as efficient, right? We just have one variable we're tracking, whereas it would have to do, you'd have to like manage the two arrays. And so if the size is small, again, it probably doesn't matter which you use. But anyway, some kind of optimizations. So I'd be interested to know how you all solved it. So send me your solutions. I'll post this information down below so you can see my solutions. Happy to receive critiques or thoughts, or again how you might have solved it differently. But again, this day is was relatively easy, assuming you knew what a hash set was. I mean, maybe you're still really new to programming, and if that's the case, that's totally fine. But a hash set would be a good thing to learn, right? So if you haven't heard of hash sets before or used them before, those are good things to learn. Even in like, I mean, back in my C days, we'd had to build it ourselves because it was in C and it didn't have the libraries, but we would have things like hash sets because they were just so useful. I even had like a little library that I took from that I used at different places that I worked that just had like functions like that, like, oh, you want to create a hash set, okay, here's how to do that, or a hash map or whatever. Those things they're really cool data structures that are like really useful for a lot of stuff. So if you know about them, I think this thing solves them pretty well. I don't know. I'd be interesting to know if anyone else has any other solutions for solving it. You probably could try and do some kind of bitwise. Seems like too much work to try and, like, you imagine you have some infinite set of bits that you're setting, and then you can just sum the bits that are ticked off. The issue you run into is, for most things, is the whole idea of an infinite two-dimensional grid. I guess the argument you could make is, oh, well, I know that what the puzzle input is. Like, you can say for sure that there's no way that this would ever produce a grid bigger than size n. So like if this is size n, the imagine the length of this string is size n, you'd know you could never go more than n this direction, n this direction, n this direction, or the n this direction. So if you just make a grid, like an array of size 2n in both directions, so you make a two-dimensional array, of 2n, you could potentially just fill in the values and then check them. Again, it's not going to be as efficient as just using a hash set. But anyway, those are ideas, just mullings. This, again, a relatively easy problem, I think. So hopefully you figured it out. If not, love to see your solutions. And we'll be back again later for day 4. Bye, everybody. Hope everything goes well for you wherever, whenever you are.